Good morning from me, evening to you, Steve, and good morning to you as well, Jeffrey. How you doing?
Hi, Ray. Good morning.
Yeah, good to talk to you. And this is the third time. It's actually usually right around January or Christmas of every year. I think I've had you on. At least last year it was just around
Yes,
Christmas time.
yes.
So
Yeah, yeah,
welcome
yeah.
back. Thank you.
Thanks for bringing me back.
Yeah, no, as I think I was just alluding to a bit earlier before we started. You have a lot of passion around the product, and it seems like you really enjoyed just speaking about it in general. So I'm sure myself and in the rest of the community always appreciates when you get a chance to come out and just talk about some of the cool stuff that's been happening with the language. So
It's always fun to talk to the community about the DAX, and that's my passion. And also connecting directly with the community is also what I really enjoy doing. So thanks for giving me the opportunity again.
Yeah,
absolutely, yeah.
we
And this,
already
go ahead,
have
Steve.
a lot of people in the comments very excited, I think, for this session. Maybe as well for people who aren't familiar with you and your relationship to DAX. Could you maybe give us an intro on that?
Sure. Yeah. I joined Microsoft more than 20 years ago to join their BI analytical engine team. So back then we were working on multidimensional models and MDX programming language. And so afterwards we always basically pivoted toward the tabular model and the DAX. So I was there from the start. And so I was one of the inventors of the DAX language and have been like watching its development for I don't know for a long time now, definitely more than 10 years. So modeling DAX is my specialty and is really got me excited.
And just to give due credit, it's like myself included, often kind of refer to you as like the grandfather or the father of DAX. So just to make sure that we like give proper shout outs, like who were the other people that you would consider to be like, some of the founders or co-founders of the language, just to give them at least a nod.
Oh, there. It's first of all, it's definitely a joint effort, and
Mm-hmm.
I don't want to lose anybody. And for example, Amir Nas is definitely there. I want to point out somebody on the patent, right? And Maris Dumitru and Akshay and me and a few other folks. So I'm not giving everybody due credit yet. Because it's been more than 10 years. I forgot exactly the final list of names on the patent, and I don't even want to say they are the only contributors to the creation of DAX.
Well, there's the phrase "it takes a village to raise a family." So like I think the same could be applied. It takes a village to write or to give birth to a language, right?
Oh, absolutely. It's definitely a joint effort and many people's contributions. Yes.
Excellent. And it's come such a long way too. I certainly remember just poking around at that all the way back from Excel 2010. Was it one of the really early versions of Office and Excel? The Power Pivot plugin that you had to go turn on manually, explicitly because
Yes.
the
Yes.
Excel
Yeah.
team would not allow it to be turned on by default, to my understanding, because it would slow down the load time of Excel. So you had to always turn it on a new install. It would never be on by default for the Power Pivot ribbon. You'd have to flip the switch to yourself. That's
Yes.
what I was
Yeah.
at least told. Yeah.
Yeah. Because back then there were also Power View, right? It's Power Pivot, Power
Oh
View.
God, yeah.
Yeah. And so yeah, that was the old time. And also even we are not sure how successful this initiative would be, but it turned out to be much better than we originally anticipated.
It was nice to see it had a nice glow up. It went from an Excel plugin to essentially it's the modeling engine now for Microsoft, like for large, for anything reporting based. So I'm sure it's been very nice to see the tool get such wide distribution. Not only Excel but into Power BI, Fabric, Azure, anywhere where any type of a semantic model needs to exist. So
Yeah. I would give Amir Nets the credit that he
yeah.
came up with the vision. I remember we were doing very well on the MOLAP engine and MDX. It is not nearly as like a widespread as DAX and the Tabular engine because of they are targeting different teams within organizations. But when Amir talked to us that, we're gonna build a new engine from scratch, it will be the BI engine for Microsoft for the next 10 years. I don't believe many of us actually believed in him. when boldly, this is the new direction, but it turned out to be the reality 10 years later.
Exactly. Yeah, just as one little last mention, I had it was a fun like fan moment when I managed to get Amir on last year to talk about Fabric and everything. But we had a similar fun little like dive into kind of some of the history and his role through things over the years, including the Power Pivot engine and all that. Kind of circling the conversation, into today and everything. It sounds like we're gonna have a good discussion on pretty much all the stuff that's happened in the last year, news, updates, things that have just evolved. So I'm really curious to hear about that, and also from you, like where would you like to get started on talking about some of the things that we have planned for this session?
Okay, yeah. So today's session is all about the DAX and especially what happened last year. So we are gonna focus on three actually unrelated developments in DAX. One is the enhancements to summarize columns. The other one is visual calculations. It's in public preview, but it has already has a lot of features enabled by default, so people can try it out already. And the last but not least are the schema info functions. And so those are the three major areas we're going to talk about, even though they are unrelated in a sense. They all actually work together to make people's DAX experience a much better one. And also, given I'm from the product team, so I'm going to go below the surface. We're not only talking about how the feature works. You can get those information already from many different sources. We are going to take one step further. We're going to look at some of the under the cover, like how the things work under the cover. And I will also, for each feature, I'm going to mention some caveats that the user should pay attention to so they don't hit a snag when they experiment with the new features.
Excellent. And I get a bit of deja vu because I remember last year it hadn't been implemented yet, but I know that there was a lot of people that were very happy by the end of the stream with your announcement that Summarize Columns would be available sometime in the future to be used in regular DAX expressions. And then I think you even went through like 3 or 4 scenarios on like when summarize columns, add column values, and all those other which was the best kind of option for building out tables in DAX.
You're right. This is exactly why I want to talk about the Summarize Columns first, because last year, almost exactly 1 year ago, we talked exactly about some. You asked me what are the potential new things that can happen to the DAX world back then, and I mentioned the Summarize Columns, and so two of the I remember back then I mentioned the 2 potential developments, and both of them have happened last year. One is Summarize Columns now can be used in measures, because despite this Summarize Columns being the core function in DAX queries for many years, it is a very special function in the sense that the vast majority of DAX functions can be used anywhere. Measures, calculated columns, and queries anywhere you like. But Summarize Columns always had this limitation that you couldn't use the measures, kind of like the most important thing for DAX users. And now it is enabled for measures. And the other one is we actually introduced, we changed the semantics of this function as well. That's quite surprising given that it's a core function in DAX queries. Why do we want to make a design change so late in the game? So I'm going to answer both questions. Okay, so let's start with Summarize Columns in measures. So to be technically accurate, you were able to use Summarize Columns in measures before, but there were a lot of limitations. And now you can pretty much use it just like any other DAX functions, as it should be. So last year we compared like different ways of achieving similar effects. So let's review some of the functions that have similar behaviors as summarized columns, but have like some differences. So the first one is the add columns. So add columns basically allow you to add what we call an extension column. During today's presentation, let me just call them measures. They don't have to be measures. They can be any DAX expressions you rapidly calculate, they behave like measures, but I don't want to just constantly saying, expressions or measures. Let's just call them measures. You know what I mean? So you can basically add a measure evaluation to any table. And in particular, many people use some grouping columns like the product column here, and then say, calculate the measure total sales value against each product. So add columns was used for this purpose. You can do something very similar using summarize function. Summarize function with one additional requirement that you have to start from a central table, typically a fact table. So you can say, use sales table as the root table, and then group by product, and then calculate the measure total sales. And now we can also do the same thing using summarize columns. You can say, I can group by the product column and then calculate the measure total sales. The difference, if we remember from last time, is add columns will include all products unconditionally, regardless if they have sales or not. So you may see a long list of products without sales, especially if you have some other filters like some country, some customer, or some like a product category. So obviously not every customer buy every product in every time duration. So in many cases, you will have a list of products that have no sales at all given the constraints, but add columns will return them nonetheless. Summarize has basically required this additional first argument. It has to have a root table. That means that if you have, for example, two fact tables, it's hard for you to write such expression, right? It's very hard for you to write an expression that is starting from two fact tables and then group by into more than one grouping columns. Summarize columns is more elegant compared to the previous two. Number one is it will automatically, it has this what we call the non-empty semantics, where basically it will automatically exclude any combinations of grouping columns that don't have the measure value, don't have sales, for example. So in this particular case, it's equivalent to add columns, but you filter the products and remove all those without any sales. And then you add the sales back in. So you can tell that to achieve this semantics previously, you have to do something like this. And then now you can just write the summarize columns, a single grouping column, and a measure. And summarize columns also make it much easier to write more than one grouping columns, especially when they are from different tables. And so it's generally make writing DAX code more elegant and simpler. And especially in measures, when you have an intermediate result, you need to calculate some measure values before you do something else. That makes it easier to write. And so let's go to a demo, go to desktop to see how exactly that works. Okay, so here I have two measures. Let me give it this two. So I have two measures, and the first one is test 1, the second one is test 2, and eventually so this summarize column is the query one. So I say the grouping column is product category, and then I calculate this against both measures, measure 1 and measure 2. The main difference is in measure 1, I'm not using summarize columns. So I'm just using the traditional way. So in this particular case, I want to calculate the average total sales against all the products whose total sales is, the product's own sales is greater than a constant number. So in the past, we can do it this way. We can just say filter the products where the total sales is greater than this value, and then do the average X over it. Now you can have a different way. You can say, I can use a summarize columns to get the product and their corresponding sales, and then I filter it away, and eventually I do the same average count. And then if I run them, the both should return the same result, which is what we can see here. They are returning the same values everywhere. But in this particular example, you can say, what's the advantage of summarize columns? Because clearly it's longer. The expression is slightly longer. And you also notice that I deliberately chose this at a sign at the symbol at the beginning to differentiate between a query, what we call extension calculation, where it's a local calculation versus the model measure. So the main difference, if you pay attention to, is in the non-summarized columns one, we use the total sales measure twice. They are model measure, they are the same model measure, but because they are used in different contexts, so I have to calculate the total sales twice in different contexts. And in the summarized columns version, I only use the total sales once. So although the results are the same, potentially this is more efficient because the model measure is calculated only once, and afterwards I just use the calculated result directly for the rest of the calculation. While the original one, because it refers to the model measure total sales twice, it will calculate the model measure twice. Of course, in the end, it depends on the complexity of the measure, all those kind of things. But in general, the more model measures you see in your expression, potentially it's more expensive to calculate. But we have all kinds of optimizations that can potentially optimize certain things away, but not in all cases. This, at least you have your own direct control over how many times a measure is calculated. Do you have any questions on this one before I move to the second example?
Some open-ended ones specifically, but those we can queue up for more of like a general Q&A section, but nothing specifically on this yet. But very active chatting and people excited about this stuff for sure.
Yeah, please keep the questions coming in the chat as well if you have any. Your chance to speak with Jeffrey here, which is a very good chance. So keep them coming.
Yeah, just one more example about the summarized columns in measures. So again, here I'm defining two equivalent measures. The 1 and the 2 are doing exactly the same thing. They are trying to find the top 3 products by sales, and then they calculate the combined sales of those 3. So before summarized columns was allowed in measures, you have one of the ways is to do like this. You can use the top 3 top n function, take top 3 products, and then sort by their total sales in descending order. And once you get you identify the top 3 products, then you can just calculate their combined total sales. That's the pre-summarized columns way. Now with summarized columns, you can again you first calculate the products and their total sales, and then do the top 3 again. But notice that once again, I'm using this @ sign here to make sure this is not a new measure, but rather just to reuse the calculation in the previous step. And then finally, I'm just summing the top 3 products by the pre-calculated total sales. So obviously, this doesn't work for distinct count or those non-additive measures, but for many of those additive measures, this again is it only refer to the total sales measure once, while in the other way you do it, you refer to the total sales twice. So it may or may not cause performance issues, but basically, generally speaking, the more direct reference in model measures in your expression, the higher chance that it will cause recalculation of the same measure, but in different contexts. And this using summarized columns is a guaranteed way for you to ensure the measure is only calculated once in this particular context, and the rest of the calculations is on basically the result of the previous step. So these are just, let me actually write to show you that the two calculations actually does exactly the same thing. So here we have a small table for each category. We're getting the sum of the top 3 products in that category. And you can see the two measures return exactly the same results. Shall we move on? Okay, let's go back to the presentation. So we have seen that now you can use a measure, you can use the summarized columns in measures. In some cases, like the one I listed above, it's a simpler, and in some other cases, it will make your measure performance potentially improved by minimizing the number of times you refer to model measures. But it's obviously not with any DAX features, there are some potential behaviors that people may not be aware of. I just want to point out that summarized columns has a particular semantics called self-valued semantics. And self-valued semantics, what this means is any filter you put in the context will only apply to the grouping columns from the same table. It will not apply to grouping columns from different tables, even if the two tables are related. This is hard to understand just by words. So again, let me go to an example to show you exactly what I mean by this so-called self-valued semantics. So come back here. So here, again, I use two measures, test 1 and test 2, and then use them in the same query. The first measure is, in this case, I use summarized columns in both measures, but the first measure just calculate for each product, give me the number of rows for that product. And then the second one is just to summarize a product. You may ask, what does it mean, summarize columns a product by a single column? What does it mean? It literally means it's equivalent to values of this product. In a sense, okay, it's not exactly the same. In a sense, basically, I'm taking the distinct values of the product. It's just you have a grouping column without a measure. It's still a grouping column, okay? And then afterwards, I just return the number of rows for the previous step. And if I look at the main query is just saying, okay, group by category. And in this particular case, unlike the previous examples, I deliberately put the category on its own table, okay? And so let me actually show you the schema. So what I mean is I have the category column here in the product table. I also have the category here in the category table. I do this just so to show you the difference between what I call the self-valued semantics. It's not a necessity for modeling purpose, just to illustrate the difference in behavior. Okay, so the category from the category table and the category from the product table, they have the same values. They just belong to different tables. So come back to the query itself and the main query. So once again, I'm using the category from the category table while the product is from the product table. Okay. So now if I run both, so you and again, so you may wonder what's the point of having this count rows? It does not need to be here other than remove it does because it's even on the same product table, so it's going to remove anything because obviously product in the product table have at least one row. So this is never going to be empty, and so it doesn't do anything. In theory, it shouldn't do anything, right? But let's see what happens. You can see that the first measure returns seems to return what we wanted is how many products are there in this category. while the second measure doesn't do anything. It seems to return all the products in the product table instead of the number of products in each category. Why the difference? This is because of what I call the self-valued semantics. And what it means is for the filter, which is the category, for each category is a filter, because it belongs to the category table, it does not filter the product table directly by itself, okay, on the grouping column. But it will filter the product table through the measures. And because the non-empty behavior, I first filter the measures, and then the measures will in turn remove any products that does not have a blank measure value. So it indirectly filters the grouping column, the product. While the second one,
go ahead.
Go ahead. You go
yeah.
ahead.
So just quickly, yeah, and like, so it took me a sec. So this is because the fact that you're like, you have, this is more of a snowflake schema. You have a category table and a product table separate in the model. Yes.
Yes, correct.
Yeah, exactly. So like it's in like that took me a quick second for it to click. If they were on the same table, if you had a product master, would your test 2 down at the bottom, would that return the same counts?
That would, because
okay, yeah.
It's my let me see if my second example exactly what you said or not. Yes, my next example is exactly what you are asking. Okay, so let's actually go to that example then. So in my second example here, and so I'm first of all, I want to explain two things. One is to answer your question: what if I set the filter on the product category instead of a category? Okay, so I will first try set the filter on category. And then next, I'm going to uncomment this one and try, I set the filter, same filter clothing on product category. Okay, so that's exactly your question. And then I'm going to test 3 different queries. The first one is my grouping column is product. And then I'm also use the same opportunity to answer another question is like, why do we design it this way? Right. So like, why don't we, this is what I call it's by design, it's called the self-values semantics or self-values behavior. That means any outside filter here will filter the grouping columns directly only if they're on the same table, but indirectly through measures if they are from different tables. So for those of you who wonder why we designed it in such a way, if you this is the second example will explain why we have this one. So I have 3 summarized columns in this case, and the first summarize they all use the product as the grouping column, all 3 of them, and they all use the same filter, the clothing category filter. And initially, I'm going to put it on the category. And after this, after we see what they do, I'm going to use the product category as the filter. Okay. And then for these 3 summarized columns, the first one doesn't have any measure. The second one has a regular measure, which is the count rows of product. The third one is almost the count rows of product, but I deliberately do a +0. It's a trick to convert blank to 0 for those people who don't want to say blank. But it has also a side effect to summarize columns, because we talked about the summarize columns will remove things that has blank values for the measure. But here, I no longer have any blank value, because I will actually, in this particular case, it shouldn't even matter. And let's just do it. Yeah, because I'm counting the product table. This only matters if I put the measure directly on the sales table. So let me write. So the first one, I don't know if you can see it. I have I have 295 rows. That's the first query, 1 of 3 here. It says 1 of 3. Okay. And that's the first result. So let's look at the second one. It's only 35 here, 35 rows. So it's obviously filtered. And the third one, is also here, and it's also not filtered. Okay, so the reason why is, let's go back to look at the 3 part. Okay, so remember, filtered, no, not filtered, filtered, not filtered. 1, 2, 3, right? So the first one, not filtered, because my filter currently is on category, and the grouping column is on product. There's no measures, therefore there's no direct filter. Nothing happens. And notice that here I'm putting the filter directly inside the summarized columns itself. So here's the reason here's for those of you who wonder, like, is it because my filter is outside the summarized columns? No, that's not the reason. The reason is even when it's inside the summarized columns, the behavior is the same. It has always been the same behavior for summarized columns. So when you put a filter, it will only filter the grouping column when they are from the same table. And then the second one, it is filtered, is not because the closing category filter applies to the grouping column, is because it applies to the measure. And then the measure indirectly filter the grouping column. The third one, it also filters the measure. I was wrong because I forgot that I put the filter on category, which is a different table of the product. Therefore, I will only return product that does have those in those category, and then we do a +0. The measure no longer have the capability of filtering the grouping column, because the measure is never blank anymore. Therefore, I go back to the seemingly non-filtered behavior. And last but not least, if I move the filter to the product table, so in this case, because the filter is on product table, the grouping is on a product table, regardless of the measures, the grouping column will be filtered because they are in the same table. So if I run them again, and let's look at the number 1 is now 35 rows. It is filtered. And I'm not gonna go to zoom in again, it's taking time. So, but if you pay attention to the bottom, to the status bar, the second one, 35 again, the third one, 35 again. So in this case, all 3 are filtered.
And I think just as a, I'll keep the terms agnostic to make sure not to accidentally use like filter versus row context. But essentially the only time the context of 2 columns is understood without some type of aggregation or scalar value like measure output is when they're from the same table. As soon as they have to traverse a relationship, something needs to be done to calculate a value, a min, max, something to a scalar output to then essentially merge those 2 together, because they don't have like a natural association with each other. There's no defined context yet outside of the measure with the what you're showing.
I think you got the gist of it. So let me go back to my presentation. I have a picture just to nice. Basically re-emphasize exactly what you said. So basically, let's say I have a filter on the category, and my grouping column is product from the product table. Right? So in the first case, when I do have a measure here, I'll call it a measure in general, then the filter will first filter the measure to give me the number of products in this category. And then because I'm going to remove any products that's when this measure value is blank. So this measure value, depending on whether it's a blank or not, will indirectly filter the product. So the filter goes to the measure first and then come back to filter the grouping column. And when you don't have a measure using summarized columns, then the filter does not apply at all, because one is on the category table, the other one is on the product table. So it's kind of like if I were to give a rule of thumb for people who want to use summarized columns in measures, I would say you want to use summarized columns only when you do have measures and good measures to boot. And if you just want to list a bunch of grouping columns, I would rather use a summarize. Summarize is good for that purpose. Summarize has some weird behavior if you have measures in it. So our general recommendation is use a summarize function if you just want to have grouping columns. But if you do need measures, then summarize columns can be a good choice in your measures.
It's just
And I think it's
very nice slide. So this is a very good slide that kind of put everything you've just spoken together. Some good rules of thumb there with summarize columns. So thank you.
Shall we move on, or any other questions about this? I know
Yeah,
I have a few. Take some time to digest. I know. Sorry. Go ahead.
Yeah, no worries. Let's just do a quick pause, and there are a couple general questions. We can use that to just chat for a few minutes. So let me go ahead and bring up a couple. I'll start from the oldest. Where's the very, very first one? I think one from Donald could be a simple yes or no, or however long you'd like to elaborate on it. But he wants to just know, like, in general, is OLAP cubes dead at all?
OLAP cubes will definitely be continuously supported by Microsoft. In other words, if you have that in your production, and you don't have to worry about Microsoft is gonna sunset OLAP cube, so you are no longer get technical support. On the other hand, there will be no new features added, or very little features added. Therefore, if you want to for example, Copilot, all those AI stuff. So basically, if you want to see continuous new features added, new capabilities added, then you want to go to tabular model. If you just want to maintain an existing OLAP cube, and just keep in mind that no new features will be added. So it will be basically frozen in time, but it will be continuously supported by Microsoft.
That's what I'd figure. I would imagine similar like to VBA and other stuff where it's like we're not developing it anymore, we're not really updating it, but we're not. It is yet to be retired in the immediate future, just because there's a lot of companies that still use it and don't want to migrate yet.
Yeah. It's not deprecated for sure.
Yeah, exactly. So it's not evolving, but not being deprecated. Let's see. One from Stephanie Bruno. I'd love to bring this one up. So she has a SQL background and has been using and trying to understand DAX for years. When might it finally click in her brain?
Well, if you so actually, how about I will answer that question later when I talk about the visual calculations. Yeah.
Oh yes, okay. I'll save that to be queued up. Let's do a couple more and then we can get back. Yeah, here's a good technical one from Bernardo. I like this one. Or sorry, Bernat. Non-selected item expression and multiple selected item expressions in calc groups. What are the main use cases? And there's a part 2 to the question. So what are the main use cases, and when will we be able to edit them in Power BI Desktop?
I can never give a timeline during public. So timeline is you have to wait for the official statements, and the primary use is for those subtitles, subtotal and grand total rows, right? If you put a calculation item column on in a table report, and you selected 3 of them or 2 of them, and then what should happen to the total value? Right, so you have 3 calculated columns selected, and the total value, what happens? So that's the primary use there.
Excellent. Steve, do we want to bring up any others, or maybe get back into the demo?
Let's get back into the demo. We've got a couple queued up. Keep them queuing up, and we'll come back and get regular questions. And there's a lot of people who want to ask you some questions, so we'll keep going for now.
Okay, great. So what we just covered is now you can use summarize columns in measures. We talked about what's the difference between the other approaches, and what are the potential pitfalls you could run into, and what's the general rule of thumb. What I say general rule of thumb is you typically use it only when you need both grouping columns and measures. And if you only need grouping columns, then summarize is a better choice in most situations. So the next enhancement to summarize columns is we changed it. We changed what it returns. Why, right? So exactly because it's such an important function, we obviously cannot just change the behavior and without telling you, without a way going back, and then it will literally affect millions of reports already deployed. So we're very cautious. We introduced a new model property called ValueFilterBehavior. It has three options: automatic, this is the default, and also today automatic means retaining the old behavior, the existing behavior, so no change at all. Coalesced is the name for the old behavior. Independent is the name for the new behavior. And we are waiting for collecting more feedback from customers before we decided when to change the automatic to independent. Okay, right now automatic still means coalesced, but in the future, depending on customer feedback, we may change automatic to independent, at least for new models. And why do we do this? Okay, it's because despite the summarize columns central status inside the DAX queries, it has a non-intuitive designed behavior, sometimes called auto-exist behavior. And so let me use a concrete example to tell you what exactly I mean by coalesced. Okay, so let's look at the query. In this query, I have defined 3 filters: filter 1, 2, 3, and then I use all 3 filters in the query summarize columns. I group by product, and then the measure is total sales. And for the 3 filters, the first filter is on the product column itself. The second filter is on the color column in the product table. And then the third filter is on the country column in the sales territory table. So 2 filters in the product table, 1 filter in the sales territory table. All right. So let me just show you exactly what is the filter context for the total sales measure. Here, by filter context, I'm talking about the filter context constructed by the summarize columns function itself before it goes to evaluate total sales. Right? So we have 1 grouping column here. That's a product column. 3 filters, filter 1, 2, 3, and on the 3 different columns. This yellow box represents the filter context constructed by summarize columns for the total sales measure, right? So we always have to say filter context for which part of the the expression. And here the yellow box is the filter context for the total sales measure. And then this is how it's constructed. Because the grouping column, filter 1 and filter 2, all from the product table, summarize columns will merge them together into a single filter. This filter will only have 2 columns, product and color, because this product and this product are the same. So they are merged together. And then the sales territory filter is all by itself because it belongs to a different table. So this is called a coalesced. What does that mean by coalesced? You can think about the join. If in SQL terms, each filter is just a table, and then I just join this by this. What it means is I will find out for this particular product, mountain bike socks, I will join with the color column. Since every product only has a single color in the product table, therefore, one of the colors will be removed as a result of this join operation or coalesce operation. So this is the coalesced behavior, okay? And then that also means that dependent for this simple measure, it doesn't matter coalesced or independent. So that's why I'm using this illustration to show you what exactly happened under hood. Even though the result for simple measures, there's no difference at all, but the things can become more complex when you have more complex measures. Let me go to the next. Before I talk about the difference, let me tell you what the independent does, okay? So the independent one is basically prevent the merge from happening anymore, okay? And then it will have some benefits, which I'm going to show you. And but let's first see what exactly is being constructed if you set the summarize columns value filter behavior to be the new independent value. This query stay the same, so we don't have to go over the query again. So we still have a one grouping column, 3 filters. The filter 1 and the 2 and the grouping column come from the same table product, and the filter 3 comes from its own table. So in this case, when you set the new behavior to independent, then the 3 filters will be added to the filter context as is. And then the grouping column, because it's filtered, remember that the filters from the same table as the grouping column will apply to the grouping column. So this grouping column product will be filtered by these both filters from the product table. Therefore, it will eventually just be mountain bike socks, right? Because it's literally the product name. So this is added as another filter, its own filter into the filter context. So now this filter context is, so regardless of the result, you would say this is what most people naturally think. That's what the summarize columns is doing, right? So very few people would imagine summarize column is doing this trick under the hood. Most people's intuitive thinking is, oh, when you have 3 filters, of course you add to the filter context as 3 different filters. They may not even think anything about the grouping columns at all, but just the 3 filters by themselves, they should be just added as is to the filter context. But that was not happening in the existing behavior. Only happens when you switch your model to independent, the new behavior. Before I go to the demo, do you have any question about the at least the difference in the 2 filter contexts constructed?
No,
I think we had a couple more questions, but those were off topic, right, Steve? Yeah.
Okay, then let me first go to the demo to show you exactly what's the difference. What's the difference? Okay, so in this example, I have only. Oh, this was an old version. So let me get rid of one thing so it does not take any effect. So let me get rid of this. So it's out of the way. This was something I did previously. Okay. So in this example, I only have 1 measure and 2 filters. The first filter is on the product table and on the model column. And then the second filter is also on the product table and on the color column. Right? And you notice that the first filter has a single value. The second filter has 2 values, white and yellow. Okay? And what this measure does is the measure is using filters function. For those of you who are not familiar with this function will tell you what filter is directly put on the color column. And I do have a filter directly on the color column, which returns a yellow and white, right? Which basically I set 2 values on the color column and 1 filter value on the model column. And by the way, this model happens to only have a single color, right? Because it happens to be the same as a product name. So it happens to have a single value, but that's beside a single color. That's beside the point here, okay? So the measure itself is saying, okay, what filters are directly put on the color column, which is white and yellow, and then return them. Yeah, I use 2CSV to convert a table to a string value because my summarized columns need to, as a measure, it always have to return a single value, cannot return a table there. So let's run it. So you notice that only white is returned here, even though I put white and yellow on the color. That's exactly because the summarized columns in the old behavior merged the 2 filters, and because mountain bike socks only have the white color, it doesn't have the yellow color. Therefore, the merged result removed 1 of the filters as a result of this merge. But if I, Sorry, let me silence
No
my
worries.
phone. And now if I go to model view, choose this model, and then here, for those of you who don't know where it is, it's in the model view, the third one here, and then this is the new property, and you can say by default it's automatic. Okay? And you have to click on the model here to see the property. And let me go back. And now if I change it from automatic to independent, remember coalesce is the old behavior, independent is the new behavior. I change it to independent, go back to the query, run it again. I will see now white and yellow, because this is literally what the user has selected on this column.
Okay.
So the main reason we changed it from coalesced to independent is because this is a more intuitive thing, right? So if in the UI, you select the 2 values on color and only 1 value on model, and then we'll say, what is my filter on color? If I tell you it's only white, that could potentially confuse a lot of users. But confusing the user is actually not the most critical thing. The most critical thing is many of the DAX calculations return unexpected result. If I go back to the slideshow, remember that in DAX, it's very often times you have to remove filters using the all function or using the remove filters function. So many people say, oh, if I remove this filter, so here, if I remove this filter on product, then I should say, now I should get 2 colors. No, that's not true if you have the coalesced behavior. In the coalesced behavior, even if you remove the filter on product here, let's say in the measure, not in this measure doesn't remove anything, but the more complex measure often do that, then you no longer get the filter on the color column. You will get some residual value on the color column, while the new behavior will give you the expected value on the color column, the filter values on the color column. So that will definitely affect the result of your report. And actually, many people got confused by auto-exist behavior. In the final slide, where I have links to many different articles and YouTube videos, and one of them is what the SQL BI team, they wrote a great article on auto-exist and explain, give you concrete example that they actually affect very basic measure values, and sometimes in a very confusing way. So the caveat of using the new filter value is it will impact your existing report, but it's very hard for you to predict or to reliably tell that, oh, this will definitely change my results. That will not. It's very, very hard. So that's why this non-intuitive behavior has been here for a long time, because for most basic measures, you will not see any difference at all. Only for a certain category of measures, you started getting very strange results, like a percentage to total. Some of those type of calculations can give you surprising results. And now we give you an opportunity to switch to the more intuitive behavior of the function.
Anything that can add the syntax sugar, as they like to call it from SQL BI, right? Yeah, it's the just making the language easier to write with better functions.
Yeah. Well, this one is a core function, especially now you can use it in measures, and it's better to point out that this value filter behavior, the new and old, when you change it to independent, it will affect everywhere. Okay, it's not just only affecting DAX queries, also DAX measures, calculated columns everywhere.
Quick question from yeah, exactly. A couple from Greg. If you want to pop that up, there you go.
Yes, we got one from Greg here. Is co-released value filter behavior more efficient in the query engine compared to independent?
I wouldn't say so. In a sense, I believe this is more likely to improve the performance, the new independent, because coalesce remember DAX is an in-memory engine. Depending on the selectivity of your filters, in order to merge them together, we have to literally do a in-memory join. So for like of course, if you enumerate the values, the filters are typically small, but I can write using a filter function using some range operators, right? So, or like when the first letter is not M, those type of things. This could result in a very large filter. And if we have to do this join together, we have to materialize both filters. Instead of keeping them as simple expressions, we have to materialize them in memory. And depending on the selectivity of each filter, we can end up having a really large filter here. And we'll have a really large materialized merged filter. And depending on the interaction with the measure later on, it can potentially, it has more likely to hurt your performance. While the new behavior, because we keep the original filters as is, we don't have to do any inner join between them, then it's much likely for us to retain the original simplicity of the filters. Therefore, their interaction with the measures is more likely to lead to better performance. I don't want to say it with like absolute this or that, but it's more likely to happen this way than that way. Yes.
You put a quarter in the jar for it depends.
Yes. But this one definitely requires actual materialized filter, and this one does not.
This is I appreciate that each time you come on, you have some really good diagrams that I think helps it, because with languages like this, these flowcharts and diagrams, I think, really help to conceptualize how the language is plugging what into where with some of this stuff. So personally, from my perspective, very useful, and I'm sure a few people in the chat are very appreciative of these. And I've taken a few screenshots to mention later on some of the cool topics we've been going through today.
Thanks. Yeah. By the way, I will definitely share the slides.
Oh yes, and like that's almost always asked is like, can I have access to the slides to review on my own time? So perfect, thank you.
Absolutely, I'll share the slide and the PDX file I used for demo.
Excellent. So two things. We're as we're getting closer to time, is there anything else specifically you'd like to show? And then whenever you're done with that, at your own pace, we'll also then still have a handful of questions left we can probably go over to wrap up at the very end as well.
Yeah. Let me definitely cover visual calculations. If we don't have time, we don't have to talk to the third one. And the visual calculations, I also want to answer one of the earlier questions, like why people struggle with DAX measures. And especially for those people, visual calculations could help them. Okay? So by the way, I have another, I had another YouTube session with Patrick and Adam on their guy in a cube video, and that particular video is all about visual calculations, so you can go there to look at it. So let me first just to show you why people are struggling with measure. That I hope that will help answer that question we skipped. Let me go to the demo directly and go to the report. Okay, so here in this report, and here in this report, I have selected some dates, and then I have put the total sales as a measure value. Okay, so if I look at the filter applied to this slide, I choose a particular color. I set the fiscal year to be 2018. I also set the filter to July. Okay, so I filter down to a single month and calculate the measure total sales, and then and then because I also set the color to be multi, and so obviously in this particular month, not every day has a sales for the multicolored product, right? So you can tell I don't have any sales on the July 1st, 3rd, 4th, or many other dates. Okay, so one of the basic calculations many people want to do is I want to take the first day of the month's sales and then do some additional calculation. But I'm not going to the complex calculation. Let's say I just want to get the first value of the first day with the sales. I want to get this 126 basically. Okay, this should be a very simple thing. But if you were to write a DAX measure, it's pretty hard. Okay? And this is surprisingly hard. This is the kind of things, even for beginners, they would expect that they should be pretty easy, but it's not. And so I defined, there are many different ways to do the measure. I just give you one way, which is the first value. And maybe I just make it bigger. And so if I look at it, I use the function called the first non-blank value. And then I said for all the selected dates, and I want to find the first date with the sales value, the total sales value. And then I only want to show it when actually I already have a total sales. You may ask, why do you want to do this? You can try it without it. I'm going to share this PBX file. Just remember, even though this doesn't seem very complicated for more experienced DAX developers, but for beginners, they would not even think like you have to do it this way, right? Very few people would even know that the first non-blank value is a function, and why I need to do all selected, why I need to do this if function. There's always a reason for it. I'm not going to the details. In the end, I write such an expression, and if I add it, this will give me 126, exactly what I want. Okay, and but if I use a visual calculation, I can say right-click, new visual calculation. There's nothing, because as I said, typically people will not just use this one as the final calculation. They want to do it with it, use other additional calculations. So let me just say versus first for now. And then I can just get rid of the things I don't care about. I have a first function. And then I can say I want to get to the total sales value here. And then I go back. As you can see, it's really getting it. By the way, to make it easier, I use a whole number as the format to make it easier for you to read these numbers in my report. So let me just go to my format, do the same format there. For my versus first, I want to format it to a whole number to make it easier to read. So it is indeed 126. Okay, but clearly the visual calculation is much easier than the measure expression that achieve the same thing. And this is also why visual calculation can potentially help you to learn DAX. And as a stepping stone, especially for those calculations that shouldn't be that hard in many people's mind. So if I go back to my presentation, here are the reasons why DAX is harder for people who come from Python or SQL. Okay, so DAX is trying to solve one problem that's for BI users is they want the business logic to be centrally stored and maintained. Okay, that means I cannot store the calculation in the report. I have to store the calculation in the model. This way, this same logic can be reused in any reports. That is a business requirement. And because of this, DAX measures are tied to the semantic model. Because they are tied to the semantic model, they are not tied to any visual. That's why when I go back to my demo here, even though the first value here, the measure, is here, and I can simply get this value right here, right? But remember, the first value is defined in the model. It doesn't know this report at all. Therefore, it doesn't even know that the total sales is also in this report. It doesn't know that. It cannot assume that. And also, it doesn't know it's already sorted. Because this sorting thing is a visual property. It's not a semantic model property. Because this measure cannot possibly know that total sales is already in the same report, it's already sorted in the way it wanted. It cannot assume that. That's the fundamental reason why the expression for the measure is more complex, because it has to work without any of those extra information. While the visual calculations is different, because it's tied to this visual. It knows that, oh, total sales is already here, and it's already sorted exactly what I want. I can just go ahead and get it. That's the fundamental reason why visual calculations simplify a large category of DAX calculations, primarily for those cross-row, cross-column, cross-granularity calculations about measures that are already in the same visual.
And there's one just thing that I'll also say is a benefit that I've found for visual calcs. It does simplify. It helps teach DAX, and for people who are learning a bit where against a large model or with a complex measure where there's it's a little too hard to write a calculation to run fast that has all these kind of logic steps in it. Sometimes you can have a measure that does maybe steps 1 through 3, and then you can have a visual calc do the last, because all it needs is information from the visual to like do A compared to B or something else. So sometimes I've actually a couple of times used it as a stepping stone to add the final calc in the visual that made the measure or made the visualization speed up 50 to 100%. So it's kind of almost like putting things back in the day in a calculated column, you know, that you could use to speed up measures sometimes to calculate a category or a label. So I found that like this has been an upgraded substitute of that sometimes when you want to break apart some of the logic layers.
Yeah. And so what Reid said is great. So basically, this is my last point on this slide, and about the benefit of visual calculations is because it's not a measure, it's guaranteed not to issue new storage engine queries by themselves, and only measures can issue storage engine queries. Visual calculations will never do that. It's guaranteed to only use the values directly from the measure queries. And so I wouldn't say measure queries is necessarily always slow, because we have all kinds of performance optimizations, like a fusion, those type of optimizations. So some measures, despite their complexity, can still be fast, but still you have to be a DAX expert to know that. Here, visual calculations will greatly simplify your mental model when you write the DAX calculations. You can only work with the limited number of columns and measures already on the same visual. You have a very simple mental model that it will guaranteed not to issue additional storage engine queries. So it will not cause performance problems in that way. And is fully aware of the sort order, is fully aware of what other measures are already there. Therefore, it can use them directly. You no longer work by yourself, which are what measures do. They work by themselves.
Exactly. I like to think that they all run on an island by themselves. Every cell, every little data point that you see is its own self-contained universe, unless you ask it to communicate with anything else.
Yeah, but since we just talked about the performance, before I wrap up today's presentation, let me just go show you that one potential caveat of the visual calculations is also it could cause performance problems in unexpected ways. Let me show you why. By the way, I'm not going to continue with the demo, with the presentation, because we're at a time. So for the last demo of today, I have two visuals side by side. They are exactly the same, except that the one on the left only has the measure and the columns, and the one on the right is the same measure, same columns, but with visual calculation. And my visual calculation in this particular case is also, I deliberately choose it to be a very simple one. It's just equal to the measure. That's not the reason I want to write the visual calculation. I just want to show the side effect if you define any visual calculation. So let me go back to my report. So I can, let me go to a performance. Oh, I didn't turn it on here. Do I have already captured it? I haven't already captured it. Okay, because this is a new installation of a desktop. Did I turn it on? No, I didn't turn it on. No, I don't want to waste your time to turn on a new feature and then go back to it. So let me just talk to it. Okay, so you notice that both are matrices. Okay, and if you also look at what's added to the rows, I have a year, quarter, month, date, and but I'm only showing you the years. You also notice that I turn off the totals, right? The row total, the column total, and the grand total. I also turn off the totals. So if you are familiar with the performance analyzer, if you run both queries and then you capture the result, the one on the left will only query the years and the product categories, of course. And That's because you can only show these numbers. There's no need to go all the way down to date, right? That can go several layers deep, and I don't need any totals. And on the right, even though I'm also only showing you the year and the categories, if you capture the query, you will see that it will calculate all the way down to the date. It's unconditional, unfortunately, today. Okay? So for visual calculations, it will always query all the totals, subtotals, grand totals, even if you don't need it, even if you explicitly turned it off in your visual.
It is something just to mention a little bit. I even on a lot of the totals and subtotals is for performance reasons. It's interesting to see how much they can actually add or subtract sometimes to like the cost of a visual, like a flat table versus a matrix. So I usually recommend to like for anybody just building those out, just be cautious of having too many turned on if you have a very deep hierarchy, especially if there's 2 or 3 levels that are just showing that are a one-to-one relationship. Make sure to turn those off. You will you can significantly increase your performance on the visual when it doesn't have to calculate all those extras.
Absolutely, yeah. So that's primarily mostly affecting the matrix visual. Many people, because matrix has a lot more subtotals values, so many people turn it off. But if you want to add a single visual calculation, even though you still don't see those values, they will be turned on under the hood. So the actual calculation will happen, not just for visual calculation itself, but also for your measures.
Exactly.
So we do have a question here about those visual calculations.
Sure.
Greg's asking, this visual characteristic that always goes down to the full granularity, so down all the hierarchy. Is this implementation detail of VisCalcs, or is it inherent to the various other DAX window functions?
It's not inherent in the function themselves. It's actually a deliberate design choice. I personally don't like it. I personally think it should honor users' option, but this is not because of the intrinsic nature of visual calculations. It doesn't need to be. Of course, visual calculations make it easier for you to plug values. For example, if I want to do a percentage to total, then of course you want the total, even though you don't want to see them. Right? I want to see the percentage value here instead of the total sales value here. Then I do need the parent values. But I think people know that. Okay, regardless, come back to here. It's not because of visual calculations must do it. It's a deliberate design decision to simplify certain type of calculations when you need them.
Exactly. Let's see. Which one? Like, there's a couple. So Jeffrey, is there anything else you'd like to show specifically left on this, or do you think we can go into a general Q&A session for these last few?
I'm not gonna. So I'm going to share my slide and my demo.
Sure.
And my slide will have one more topic on the info function. I'm not going there. We're already at the time. So, but you can read it by yourself, and you can ask questions offline later on. So let's go to general Q&A then.
Excellent. Pull this up. I'll go for some of the older ones. Bring those up. So Alex Bardot had a really good one. Are we going to see any blendings of the various new DAX features like calculation groups or visual calcs?
One of the beauties about Power BI is almost all the new features work well with existing features, right? So visual calculations will definitely work with all the existing features, including calculation groups. But remember, calculation groups are also defined in the model. Therefore, they only apply to model calculations, which are measures. They don't apply to visual calculations.
Okay.
So they work in different layers.
Yeah, exactly. I think they, as you said, different layers serving different purposes, but also built in different environments to a degree. Yes. With those layers. So yeah,
and the different mental models as well, right? Because in calculations groups, I can also invoke any measures, and the measures will, in general, go to the storage engine queries. And we already said visual calculations, one of the greatest simplification it provides to the users is a simple mental model. I guarantee I will not go to any storage engine ever again. So the calculation groups obviously have a different mental model.
Let's see. I like this one from Greggy. If can be optionally, it can be lazy or strict based on query planner optimization. If eager is guaranteed to use strict evaluation semantics, will there ever be an if lazy to assure lazy semantics?
By eager or lazy, typically we are referring to like a conditional calculations, right? So and many people ask can DAX provide the capability about don't evaluate something if the condition is not true, right? Basically do a conditional calculation, evaluation of a sub-expression based on the result of the previous step. Many people, when they say eager and lazy, they are talking about can I avoid a certain type of calculations and not just calculating the result. Can you stop even look at that expression, right? If the condition is false, just don't even bother. Be lazy. Don't even analyze that expression, because sometimes the performance overhead is not from the calculation, the values of the calculation, but the simple fact that by looking at it, analyzing the calculation is taking a lot of time, like for dependency analysis, those kind of things. And especially for measures, calling other measures, the underlying expression can be very complex. And the answer to that question is no. DAX will never do a partial evaluation first and then decide whether to even look at a sub-expression. We don't have those type of laziness plan at all. DAX always look at the entire expression. They may not evaluate them, they have to look at them first. We don't have the true laziness is stop looking. MDX does have that capability. DAX worked. And that was a very deliberate decision from day one of DAX design.
There's a couple questions left that I want to bring up. I don't think we'll have enough time for all of them, but let's at least do a couple more. This will be an easy one. Let's just knock this one out. So Bernat had one just to ask, who came up with the auto exist name out of curiosity?
Auto exist was actually an MDX term. Okay. So we inherited from MDX. And let me tell you what it means, okay? So in MDX, what it means is if my query has return two columns, right? One is the year, one is the month. I definitely don't want to say, year and month is a bad example. One is the product name, one is the product color. If I need to return both columns in the query result, obviously I don't want to see, I only want to see product with its own color, right? I don't care about the combination of products with other colors. Every product has only one color, right? So that's the nature of auto exist. So basically, you only want to return values that exist in the underlying table when the two columns are from the same table.
And I remember seeing it way back from the MDX days, so that makes sense that it was an inherited term from that.
Yeah, it's inherited from MDX. Yes.
I think one more fun. Go ahead, Steve.
I was going to say we have another interesting one from Bernat, I think, from back for visual calcs and conditional formatting. So will you ever be able to use visual calcs for conditional formatting?
It's definitely in the backlog. I don't remember its priority. Can we already? I think it's already implemented. Is it? I remember you can already do it. I don't know if you want to try it, but I think we might be able to already do something about that. But it's right now, I have to say, all this formatting option is hidden really, really well. And so you may have to look it up. Yes, it's definitely definitely in the backlog in the past. I remember it's already done. It's by the UI team, but you have to double check on it.
Excellent. Perfect. All right, let's maybe do. There's a couple more like deep dive technical ones, but again, we're getting approached on the time. So I want to do one more fun one from James. I really like this one. So if you had unlimited time and budget, what feature would you would add to DAX? So basically, you wave the magic wand. What's the thing that you'd love to put in yourself?
Oh, that's a good one. There. Let me think. Well,
I like that one.
It's not a limited budget per se, but basically right now AI is all the rage, right? So DAX is definitely has a learning curve. So my personal passion, and is actually have been focusing on recently, is to leverage AI to enable people to learn DAX better. And AI is getting really good at DAX, and can provide an excellent educational tool for users in their own report. Right? Nobody wants to go to a tutorial to learn things, because then they have to, before they learn DAX, they have to learn the database, right? They have to learn, okay, what's in that model, what are the tables, what's the relationships. But people already automatically know their own data, their own thing. So they can skip over a huge part of the learning by directly go to the DAX portion. And that only works if through AI, right? Only AI can enable that capabilities.
And so, just to your point a little bit is I'm sure Copilot will get there, because like if you ask, say, if you copy a bit of DAX code to ChatGPT, the only context it knows is the code. It doesn't know the model, all the other stuff. But
yes,
it is really good at asking it to summarize. So if there's times where like if I'm given like you know, a file that's been, you know, hot potatoed over to me, like, hey, you know, you manage this, there's no documentation, really long measures, or like, you know, stored procedures in SQL, things like that, asking it to explain to you what was a person who didn't document this, what were they trying to do in this code, and it can explain it to you a little bit, like interpret what the code was. So I can imagine that future where with a Copilot that's secured and everything, that has full access to the full model, the report layer, everything, so it can analyze everything end to end, and then it could look at a measure that's complex or calculate a column and give a fairly good interpretation on, oh, given the structure of everything that I see, I believe that this thing was trying to do blah, 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 whatever it might be. But I think it could be really useful for that teaching method. It's not writing code for you necessarily, but it is explaining complex code that would take you a lot longer to interpret yourself.
Yeah, absolutely. By the way, AI is getting good at writing code as well. The progress was amazing. Yes, it's amazing. But exactly as you said, one of the obviously the benefit of using a Copilot directly inside your Power BI development environment is you no longer need to provide the schema yourself. Right, so we just automatically send the schema to large language model, and along with your question, so it will have the full context to answer the question instead of you have to somehow. There are many people out there teach you how to do it, but you have to do it, and but in the Copilot directly embedded into desktop or other dev environment, that becomes much easier. You no longer need to worry about that.
But this has been overall really fantastic, Jeffrey, and I'm very happy to have gone from like, oh, we're getting summarized columns in Measure soon, to now like finally have this solidify, because it's I'm sure for many of the people who like actually spend a lot of time in DAX, like that has been a very strongly welcomed or wanted feature for a while, because while you've explained, there is not always a perfect scenario of always use summarize or always use summarized columns. There's some exceptions of when to use what, but I think globally this has lowered the knowledge cost for people to like summarize a table inside of a measure easily without having to do without having to know quite as much about the DAX language to get across the finish line. So I'm really happy that that's now available in a broader use now for that. So really cool to see a deep dive from you today on that.
Yeah, that's a good point. Yeah, especially since it's released around the same time as a DAX query view. So more and more people are really writing DAX queries themselves, especially for people come from SQL and Python. Maybe DAX query view is more comfortable to them than just the visual, because they cannot see everything. But the summarized columns is heavily used in DAX query view. Therefore, if you are already familiar with it in one environment, many people want to stick to their knowledge when they go back to the measures. So this will be able to allow them to leverage the knowledge that they already acquired instead of saying, here you have to do it this way, and there you do it that way. That makes the learning more difficult.
Exactly. The rising waters raise all ships is one of my favorite terms for these kind of things. And it seems like, as just a final comment on that, like that one of your biggest passions now from that question of what would you want to do next is really focusing on making DAX easier to learn for a broader audience, or just making DAX easier.
That has always been my passion. Actually, one of the reasons why many people call me the father of DAX is because I was the first one to realize that the DAX can be quite challenging for beginners. So I spent years trying to teach people how to think the DAX way, and now with AI, that's definitely another one of my passion that will enable me to amplify my knowledge in more scale it to more people more easily instead of doing one meeting at a time.
And I'm looking forward again to bringing you back on in another 12 to 16 months. And I'm sure, especially as you mentioned with AI stuff, there'll be ample opportunity to discuss some even more stuff. So thank you so much for coming on today for this.
Yeah, that'd be great. I'm really happy to join you in the future. And thanks again for inviting me back to this. And we can actually pick up exactly where we left off from last year's session.
Very
Excellent.
technical, very, very enlightening. So thank you so much.
Yes,
so with that, thank you for coming on. I love the amount of the chats from everyone and the questions, especially the deep dive ones. There's a few that I know love every time you come on, Jeff, and clearly the community shows how excited they get when they get a chance to ask you some deep dive questions. So thank you for that. And then of course, once you hand over a PDF of the slide, we'll make that available in the description below in the YouTube for people to download. But yeah, thanks again for coming on, and otherwise Thursday. So yeah, have a great Friday and rest of your weekend as well.
Yeah, I'll send them over to you, and then you can share with the community. So yeah, great. Thanks everyone for attending today's live stream, and it's really a pleasure. Thanks, Steve. Thanks, Reid, for bringing me back. Thank you.
Absolutely. Yeah. Until next time.